So now we're gonna basically go through the all the bones of the body. All right, you should have already watched the video on the bones of the skull, and now we're just gonna do the rest of the body. You can see here the bones that are colored in blue, right? The blue color bones, that's called the axial bone. Axial bones, okay? And that kind of forms the core frame of your skeleton, and everything else just kind of hang onto this frame. And so the ones that are shown in white are called appendicular bones. So the axial bones include bones of the skull, rib cage, as well as your vertebral column, right? And everything else is going to be your appendicular bone. So like I said, you should have watched the video on the labeling of the skull, and if you haven't already, please do so. And everything I said in the videos are basically the same material that are on these slides, so please go through these slides yourself after you've watched the skull labeling video. So now we're gonna move on to the spinal cord. Okay, sorry, spinal column, not spinal cord, spinal column, which is also known as your vertebral column. So your backbone is made up of various vertebrae, right? So individually we call them vertebra, and collectively, plural, we call them vertebrae. So there are 7 cervical vertebrae here. These are the bones that makes up your neck. 12 thoracic vertebrae, right? These are the ones that forms your thoracic region, spine. And then we have 5 lumbar bones here at the bottom. We have the sacrum, which is 5 bones fused together. And lastly, we have the coccyx bones. Okay, so these are 3 to 5 bones fused together. If we are talking about like an animal with a tail, then this is what's going to become their tail. Okay, so we don't have a tail, but we have a tailbone, right? That's basically what this is. So in this model, you can see the curvature of your backbone, right? It's convex at the cervical region, and then we have concave in the thoracic region, and then we're going to have convex again in the lumbar region. It wasn't always like this, right? When you were still a baby, your backbone is pretty much straight. It's not until when you start to learn how to crawl and lift your head up that the weight of the head would help shape the curvature of your backbone. And eventually when you start walking at around 1 year, then the weight of the upper body will help shape the rest of the backbone. So another thing you can see here is the vertebra. They actually are very similar in terms of shapes, but they do get bigger as you go down. Kind of makes sense, right? You have to support the weight of everything above it, so you need them to increase in size to be able to do that. Now I want to just kind of turn off everything else here and focus on the cervical vertebrae. And here we have 7 cervical vertebrae. Again, these are the bones that makes up your neck, right? So 1, 2, 3, 4, 5, 6, 7 there. Now the first 2, right, C1 and C2 is kind of special, so we give them special name, right? This one is what we call the atlas, and then this one is what we call axis. Okay, so C1 is atlas, C2 is axis. If you have trouble remembering that, one student told me alphabetically T comes before X, so C1 is atlas, and then C2 is axis. Now what's interesting is if you look at the top of your atlas, you can see 2 round kind of indentation here, and that is actually where the occipital condyle from the occipital bone will articulate with, right? And that forms a joint that allows you to nod your head. If you take a look at C1 and C2, you can see there is a protrusion in C2 that goes through the center of C1. And this allows you to form what's called a pivot joint. And the pivot joint lets you turn the head side to side. So if you nod your head and say yes, that's the connection between the occipital condyle in the skull with the C1. And if you're shaking your head, that's the connection between C1 and C2 through these pivot joint. So let's switch back to the PowerPoint here. You know, that's what I was talking about earlier with the agles and the axis, and you can just read through the slide here yourself. Let's take a look at the individual vertebra. Right, so they kind of stack with each other on top, one on top of the other. Even though they are going to be increasing in size, but there are structures that are similar to all of them. At the back here, we have what's called the spinous process. At the top, we have the superior articulate process, and here we have the inferior articulate process. So it all sounds really complicated, but actually, if you take a look at the model, it's quite straightforward. So these are the thoracic vertebrae, and you can see at the back, sticking out at the back, these little things that are pointing out are the spinous process. So basically, the spinous process would lock onto each other so that you can only bend forward but not backwards too much, right? If you arch your back too much, then these things actually gets in the way, and that's a good thing. You don't want your backbone to be too wobbly, right? You want to have some kind of support, right? And the spinous process just make sure that you are not going to be overarching yourself towards the back. Of course, some people are more flexible than others, but typically these would prevent you from bending backwards too much. If you look at this would be a T1, your first thoracic vertebra. So T1 here, you can see there are two connecting points here. These would be the superior articulate process, and you can see at the bottom right here, right there, would be the inferior articulate process. So to put it in a sentence, basically the inferior articulate process of T1 is going to connect with the superior articulate process of T2, right? And the inferior articulate process of T2 will then in turn connect with the superior articulate process of T3, and so on and so forth, right? So basically they are kind of like jigsaw puzzle, right? One fits into the other. Now you cannot really see it here because I turned off the connective tissue. Oh, okay, there we go. So after I turn the connective tissue back on, you can see in between the vertebra, there is actually a little bit of cartilage, right? And the cartilage, it kind of cushions the connections, allowing you to bend your backbone without having the bones rubbing against each other, right? So it reduces friction and it prevents wear and tear. Sometimes as part of aging, these things can get thin, and you sometimes might have a slip disc and it might fall out, and that's when the two bones are going to be kind of coming together a little bit too close. And on the side here, you can see where the two bones connect with each other. There is a hole there, and this hole is actually called the intervertebral foramen. That's where your spinal nerve comes out. So as I was saying, if the disc comes out or if it becomes too thin, then these bones might be crushing each other and pinching on the spinal nerve that comes out on the side, and that might give you numbness, for example, in the limbs, right, or some tingly sensations. So you would have to do physio to correct that. So here you can see what I was talking about in the model, right? The spinal nerve coming out through the intervertebral foramen. Again, foramen is just a hole, so this is a hole that exists in between two vertebrae. Next, we are going to look at the rib cage. Your rib cage is formed by the ribs as well as your sternum. So let's take a look at the model. Over here, you can see that the sternum is in the along the midline, and your sternum actually has 3 parts to it. Let me try to label them for you. This here is the manubrium. Okay, so the manubrium is where the first rib and the second rib connects to. All right, you have a total of 12 pairs of ribs, right? And they some of them connects to the sternum, some of them don't. Rib number 1 and number 2 connects to the manubrium. Okay. Next, we have the body of the sternum, right? It's literally called the body, and that's where the second rib all the way to number 7 connects to. Okay, so second rib kind of connects at the boundary of the manubrium and the body, right? At the interface right here, and then 3, 4, 5, 6, 7 connects to the body. And finally, we have a notch here. This is called the xiphoid process, right? No ribs connects to the xiphoid process, but this is a connecting point for your diaphragm. Okay, so let's take a closer look at the ribs. The ribs originates at the back from the thoracic vertebrae, right? So T1 is where the first pair comes from, T2 is where the second pair comes from, so on and so forth. And like I said, you have a total of 12 pairs. So let's take a look at rib number 1 through 7. So 1, 2, 3, 4, 5, 6, 7. These are called true ribs. They're true ribs because they connect to the sternum through their own cartilage. Okay, so these are called costal cartilage. So the first pair has its own costal cartilage, and all the way to number 7 has its own costal cartilage, right? So 1 through 7, we call them true ribs. The next 5 are what we call false ribs. Okay, so let's take a look at number 8. Number 8 does not connect directly to the sternum. Rather, its costal cartilage is going to connect to the costal cartilage of number 7, and then it's going to go to the sternum, right? So these ones that don't have their own connection to the sternum, we call them false ribs. So 7 pairs of true ribs, 5 pairs of false ribs. Okay, so 8 here, 9, 10, 11, 12, they're all called false ribs. 11 and 12 are special in the sense that they don't even have any cartilage. Okay, they just kind of, comes out and then kind of stop in the middle of nowhere, so to speak. These are also called floating ribs. Okay, so one more time, 1 to 7 true ribs, 8, 9, 10, 11, 12, they are all false ribs, and 11 and 12, they are part of the false ribs, but we also call them floating ribs because they're just kind of floating there, and they don't have any cartilage to it. So basically, all the information is written on the slides. You can read that on your own. This talks about the sternum, the manubrium, the body, the xiphoid. Right? You can also read that yourself.